Welcome back. Today we're breaking down a soil science concept that sounds technical, but is actually very logical once you understand it. We're talking about cation exchange capacity, or CEC. If you're preparing for the ISA certified arborist exam, this is one of those concepts that quietly connects soil texture, fertilization, nutrient deficiencies, pH, and tree decline. Let's start simple. What is a cation? A cation is just a positively charged ion. That's it. Think cation. Cats are paucitive. In soils, many essential plant nutrients are cations, including calcium, Ca, magnesium, Mg, potassium, K, ammonium, NH, hydrogen, H. Notice something important. Many nutrients trees need carry a positive charge. That charge determines how they interact with soil. Soil has charges too. Soil particles, especially clay and organic matter, carry negative charges on their surfaces. Opposites attract. Negatively charged soil particles attract and hold positively charged nutrient ions. This is critical. Without this attraction, nutrients would simply wash away with rain or irrigation. Sandy soils have very little surface charge. Clay soils and organic matter have much more. This difference explains a lot of what happens in soil fertility. What is cation exchange capacity? Cation exchange capacity, CEC, is the soil's ability to hold and exchange positively charged nutrient ions. In practical terms, it's how many nutrient parking spaces the soil has. Imagine soil as a parking lot. Each negative charge is a parking space. Each nutrient cation is a car. More spaces equals higher CEC. Fewer spaces equals lower CEC. That's the capacity part. Why is it called exchange? The word exchange is just as important as capacity. Nutrients are not permanently glued to soil particles. Roots can release hydrogen ions, H, into the soil. When that happens, hydrogen swaps places with another cation, like calcium or potassium. That nutrient is released into soil solution and absorbed by the root. It's a constant swap system. Soil holds nutrients, but roots can trade for them. That's CEC in action. Sandy versus clay soils. This is where ISA exam questions often focus. Sandy soils have large particles, low surface area, a few negative charges, low CEC, nutrients leach easily. Common in places like Florida, trees in sandy soils often require lighter, more frequent fertilization. Clay soils have tiny particles, massive surface area, many negative charges, high CEC, hold nutrients more effectively. But remember, high CEC doesn't guarantee good drainage or root health. Compaction can still limit uptake. The role of organic matter. Organic matter dramatically increases CEC. Humus has an exceptionally high charge capacity. This is one reason mulching is so beneficial for trees. It doesn't just conserve moisture. As it breaks down, it increases the soil's nutrient holding capacity. That's exam relevant. If you see a question connecting compost, soil improvement, and nutrient retention, think CEC. CEC and soil pH. Now we add one more layer. Hydrogen H is also a cation. In acidic soils, many exchange sites are occupied by hydrogen. That means fewer spots are available for calcium, magnesium, and potassium. This is where base saturation comes in. Base saturation refers to how many exchange sites are occupied by nutrient bases like Ca, Mg, and K instead of hydrogen. Low pH, more hydrogen, lower base saturation. Understanding this helps interpret soil tests, something the ISA exam may reference. Why this matters for arborists: CEC effects, fertilization strategy, nutrient deficiency symptoms, soil test interpretation, urban soil management, and tree decline diagnostics. If soil has low CEC, nutrients won't remain long. If soil has high CEC, nutrients are retained better. But physical soil issues may still limit uptake. CEC explains why sandy soils often show nutrient stress faster than clay or organic rich soils. Sample exam question. Which soil type would most likely have the highest cation exchange capacity? A, coarse sand, B, sandy loam, C, clay loam, D, gravel. Correct answer, C, clay loam, because clay particles provide more negatively charged exchange sites. Exam takeaways. If you remember nothing else, remember this. CEC equals nutrient holding capacity. Cations are positively charged nutrients. Clay and organic matter increase CEC. Sandy soils have low CEC. Roots exchange hydrogen ions for nutrients. CEC connects directly to soil fertility and pH. Understand CEC, and you understand a major foundation of soil science. And soil science shows up throughout the ISA Certified Arborist exam, from planting to decline to fertilization strategies. Master this concept, and other soil questions become much easier. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge one domain at a time.